Start, we were waiting for 5 minutes. So for the attendees are 35 in numbers. Okay, anyway. Can you see my slide?
Yes, ma'am. Yes, ma'am.
Visible, right? Okay. So today's topic is about symbolic data. Data with respect to SICP, what were the different types of data you handled? Students, what are the different types of data did you handle? Any one of you? What are the different types of data you handled so far? You have written many programs. You have written many procedures. You have written many complex procedures. Any one of you? You might have written a program using integers, numbers. You might have taken numbers, right? Or you may take a string constants, right? So now, what is meant by symbolic data? For example, if I take a mathematical expression, f of x equal to ax plus b plus something, okay? F of x equal to ax square plus bx plus c, consider. Now, did you write a program which will take this expression as a data? So that means ax square plus bx plus c, as it is, it has to be taken out. Did you handle that kind of data? So in many times, we have to represent some mathematical expressions. For example, the polynomials, right? So I say that 4x plus 2x plus 5. Can you represent? So what happens so far? You are writing a procedure which will take the expression and it will substitute the value of x in that expression. If I say 4x plus 2x or something, instead of x, the data will be substituted, isn't it? But in many applications, I have to consider the expression as it is. Okay, so p of x equal to 6x plus c. That 6x, the x is the data, c is the data. It has to be considered as it is. Your interpreter should not substitute a value. Okay, so how to handle that symbolic data? So that is the topic of today. I hope you understood. So far, you have learned many procedures and also the constructs, let, cons, lambda, and sequence of cons and a tree, etc., etc. And you have written a procedure which will operate only on numbers, right? Suppose you are writing a procedure for finding a factorial, okay? Factorial of n is n into factor of n minus 1. You have written a logic. But what happens for n or n minus 1? In place of n, the data will be substituted and the expression will be evaluated, right? So now I would like to have a data like this, A, B, C, D, right? The data itself, A, B, C, D. But you can construct a list with some numbers. This is fine. But how will you construct a list with the symbol A and another symbol B, etc.? How to construct a list with symbols? If you look at this example, there are many names, Anna, Lauren, etc., Molly, etc. So here, we should not substitute a value for this Molly or Anna, but we have to consider this as a data, right? For Anna, you should not substitute some value. You don't have a define statement. Define Anna 11. Okay, 11 will be substituted in the previous case what you have worked on. But now this Anna and Molly has to be considered as a data, right? It is a string data. So how to construct a list with symbols? So in this case, A, B, C, D are called as symbols. In the next example, we have Molly, Anna, Lauren, etc. These are all symbols. Okay, how to work on this? That is the topic of today. Okay, so now if you consider the symbols, what is the main thing, primary thing you will recall? The symbol will represent a expression. It will look like an expression. For example, in this case, plus x9. What is this? This is an expression x plus 9. Right? If you take this one factor of n, if n equal to 1, return 1, otherwise n into factor of n minus 1. You just look at this as an expression. Okay, so if you go to the internal logic interpreter, what it does, it is substituting the value for n, right? But now we want to work on the symbols, okay? But you want to manipulate the symbols, okay? So in our language, so how to do that? Okay, so this SICP, the Lisp program is a very older one. This language is a very older one. That time itself, they have thought about this, how to work on the symbols. Okay, any language if you take, it has to have a facility of including the symbols. Okay, so it should not take all the symbols as a variable, and whenever the variable is occurring, it should not substitute the value. Okay, that is not the normal, that is the normal behavior, but this also has to be considered in our language. Okay, so now how to work on the symbol? The language has to give a facility, and the interpreter has to differentiate between the variables, okay, and the symbol, isn't it? So how to? We can have a code. We can use the code in order to differentiate between variable and a symbol. If it is a variable x, define x something, yeah, and then x equal to x plus 2, we can write. But I want to define x as a symbol, then you include the code. Understood? Students, are you there?
Yes, ma'am.
Okay, so now we have to use the symbol code. You can use this string as well, or this symbol, this particular character. I would like to create a list of characters. I would like to create a list of characters. The list contains A, B, C, D. How to create? How to create this? What you have to do is, in front of A, you just put a quote. If you say just list A, B, C, D, and a value of A, C, D will be substituted. And in the earlier cases, the statements you will have define A2, define B3, define C4, like that. Then what will happen is the output will be 2, 3, 4, 5, etc. But I want to construct a list. List contains A, B, C, D. What you have to do is, before each symbol, place a prefix single quote. Okay, so this is a very simple provision provided by the language. This way, the interpreter will differentiate whether the given variable is a symbol or a variable. Okay, so A here, because it is an inverted comma, right? It's a single quote A, and we say that A is a symbol, B is a symbol, C is a symbol, D is a symbol. So now, can you tell me how to create this list? The list contains Anna 7, John 4. Right? So how will you create? How will you write a statement? How will you write a statement for this? Any one of you? how to create this list. The list contains two sublists. The first list has two elements and second list has another two elements. How to create this? Always you have to start with a list. We are going to create a list and inside another list, so list which contains Anna and 7. Anna is a symbol. And the next one is list John 4. John is a symbol, so you have to put a single quote. So now when you see this example, you can easily remember in C language or C++ or whatever, if you want to specify the string within double quote, you will say. When you are writing an article, okay, or something, you want to quote something, then you will put a double quote, isn't it? In a C or C++ or C# or Java, the strings will be enclosed in a double quote. In such a, if you are equating that concept here, considering Anna as a string, it will have a prefix single quote, but it will not have an ending single quote. Okay, so this will not have a ending single quote. So, but it is a string data. Yeah, you can also equate like that. So, in some natural language processing, given a paragraph, or suppose I say that, say loudly your name. I'm just asking, say loudly your name. What you will say? My name is Priya, or my name is something Anand, or whatever. But I am saying that say loudly within double quote your name. What is the response you will give? Say within double quote your name. Say your name loudly. You will say your name. Your name is the answer, right? So in that case, your name you are giving in a double quote, isn't it? So now something, actual data, that actual data will be in a double quote. You have to say as. So here, Anna, you have to say as it is. John, you have to say as it is. The Lisp interpreter has to interpret this as it is. Anna, it has to be taken as it is. Don't substitute. Don't try to see Anna as a variable. Okay, don't try to substitute a value for Anna or John. Okay, that is what we are saying here. So now we are working on the symbolic data. How to use the symbolic data? The symbolic data will have a prefix of single quote. Okay, so you are instructing the interpreter, you take the data as it is. Don't try to interpret. Don't try to substitute the value for that. I hope you understood here. Okay. So now let's have a small example. Define A is 5. Define B7. Now you are going to construct a list AB. What is the output you will expect?
5 and 7 list.
5, 5, 7. Yeah. So the output will be a 5, 7. If I go to another mode, I can able to write it here. Yeah. Just make it big. So the output of this is, what is that? Single quote, and then you will have 5, you will have 7. Okay. Now you take this list, single quote A, B. So what it will be?
List of A7.
List of A and then 7. So here what happens? What you are saying, A you consider as a symbol and B it is a normal variable. So the interpreter has to substitute a value. So that A is printed here and then the value of B7 is substituted. Now take this. What is the output?
List of A and B.
List of A, B. Yes, very good. List of A, B. Okay, so I hope you understood better. So if you want to work on the symbolic data, whenever you want the symbolic data, have a prefix of single quote. So if you have a single quote, it will be printed as it is. In this example, A is in a single quote, so A is printed. A, B, both are in a single quote, you will have a list with A, B. Okay. So now let us talk about selectors. We know how to construct a list with the symbols. Now let's go for the selectors. So now I want to apply car A, B, C. So car of ABC, if you take this one alone, it is what? It is a list, isn't it? This is a list. In the list, you are applying a car. So what will be the output? Okay, now I just go for Dr. Racket. I explain and show you. Can you see a Dr. Racket environment?
Yes, ma'am.
Okay. So now I would like to execute a command car, and then I'm going to construct a list with a symbol A, symbol B, and symbol C. So what will be the answer?
A.
What will be the answer? A. Right? This is a symbol. The symbol is returned. Okay. Now I'm just writing car of okay. So here what will be the output?
The
Students,
variable A.
variable A. Why variable A? Actually, if you look at this list ABC, this is equivalent to this one, right? Equivalent to this one, right? So you have constructed a list with ABC, so it will return you A. Okay, so this is equivalent to this particular single quote ABC is equivalent to list ABC. Okay, so that it will return you A. Okay. Now I would like to have a define. Consider it is A3. Okay, A3, and then one more define B as 5, and then define C as 10. Okay. Now I would like to construct a list of AB. So what? How to write? I want to construct a list with AB. What is the statement? I want to construct a list with AB. So consider list A, B. So what is the output you will expect? A is 3, B is 5. So list AB, yes, you will get 3 and 5. Your list is constructed. But I want AB as a symbol. So how to construct? The list will go to B. So in this case, you will get a list with AB, isn't it? Now let us say like I want to apply the selector car of list with the symbols A, B, and C. So the output will be, because the list contains a symbol A, B, C, and the car will always return you the first element. So here the first element is the symbol A. Okay. So this is working as per our expectation because we understood the concept of symbolic data. Okay, so now list A, B and C. I'm just giving you more example. I'm just explaining you the same only. So list ABC, which will return ABC. Now you see that this is equivalent to this one, right? In your program, if you are writing list ABC with a prefix of single quote, it is constructing a list with the symbols, right? Okay. Now let's take another example. I say CDR, just a minute. So CDR, then I'm going to construct a list, means X1, X2, and then Y1, Y2, yeah. So if you take this CDR, there is a list inside, there are two elements, there are two lists, right? The CDR will return you what? The CDR has to return you this one, right? The second element. The second element is nothing but a second sublist. So now we are working with a symbol, isn't it? It is not substituting anything. It is not giving you error at all. Why? Because the list does not have a value for Y1, does not have a value for Y2. So the list is not throwing an error. Okay? Why? Because we say that it is a symbol. It's all symbol. So now we can, this Lisp language provides a facility for working with the symbolic data. Okay, we can construct a list of symbolic data, and we also have a selectors which will work on the symbolic data. So the selector CDR here, the CDR can work on the symbols, right? So now the CDR is giving you the second element because the list has two elements. Isn't it? Okay. Now let us see. I take a CADR of same example. We will take X1, X2 is one list, Y1, Y2 is another list. Whatever I say, see here, CADR, first we have to apply the CDR and then apply the car. If you look at the previous example, CDR is returning a list inside another list. So now if I say a car, for this it will give you your simple list, Y1, Y2. Yeah. So now we can also apply the shorthand version of the selectors as well to the symbolic data. That's what I would like to emphasize. Okay, so now let us go on further as we understood how to work on the symbolic data. Now let's write a program. Write a Lisp program to check whether the symbol exists in the given list or not. Whether the symbol exists in the given list or not. For example, I'm just giving a list. The list may have 1, 2, 3, A, Z, right? So given the list, a symbol, whatever the symbol I say, for example, X is a symbol present in the list or not. We have to write a program. Okay, so now, so far you have written a procedure. This procedure will take parameters, and if you look at the parameters, it may be a list or simple numbers, right? That we know. But now we want to work on the symbol, and we want to write a procedure which will manipulate or which will find out something on the list of symbols. Okay, so now let us write a procedure which will find out the given symbol is present in the list or not. We have to do. How will you do? This list is a bigger list. It has many elements. And the symbol, what I'm giving is a simple symbol. For example, it can be A or B or X or whatever. Whatever I am giving, it has to find out, this procedure has to find out whether the symbol is present in the list or not. It is like a searching, right? Search element 5 in the list contains 1, 2, 3, 4, 5. Whether the 5 is present in the list or not, you have to search. And we already wrote a procedure for a linear search using the recursion, right? By using the car or CDR, whatever, we have built a logic. The same logic, let us apply for the symbols. So now I have given you a small fragment. I just started defining a function. Symbol is available or not. Okay, I have to check symbol is available or not given the symbol and the list. Okay, so but you can use different cont and the recursive version we can have. So now first of all, what you will check in this particular program, I'm thinking that I have a hope, I have a confidence that you understood the problem, but now we have to write a program. How will you write? First of all, what you will check. There are many conditions. For example, the list may be a null, or the list may contain a single element, or it may contain multiple elements, right? So there are three possibilities. The list may be empty, or the list may contain a single element, or this list may contain multiple elements. So in that case, how to write a program? First of all, I have to check whether the list is null or not. How to check? What is the first condition? How will you check? How will you check LI is a null or not? If it is null, the procedure has to return you false. How to check? You have to check null. Have you heard about this? Null question mark? Null question mark X, sorry, here it is LI, isn't it? So this Li is the list and the list is null or not. I'm just checking. It may give you true or false, right? If it is null, what you have to return? I have to return false. Okay, this is the first condition. Next condition. What is the next condition? The next condition is, tell me. What is the next condition? Just now I told. If the list contains only one element and that element is a symbol, then you have to return that element. Okay, I will write. So equate. Question mark. This particular procedure, you know it, right? What it will do? It will check the given symbol, okay, and then you are taking a car of Li, okay, both are matching. If both are matching, then you return the symbol. See, symbol is nothing but car of Li. This is the boundary condition checking, right? The first element itself, the given symbol, then you can just return the symbol. The symbol is available. Okay. Otherwise, what you have to do? So I may write else the function name is what? I have to call the same function, okay, and by passing the symbol, okay, but now the list is CDR of X. Can you understand what I'm saying? If the list is null, return the false. If the symbol and the car of the list, you no need to further go to the iteration, right? You just return the symbol, or you can also return the true. Otherwise what you have to do is call the procedure, okay, by passing the symbol, but you have to start with the second data unverse. So CDR of what it is? Li. CDR of Li. So whether it will work or not. Students, whether it will work or not. You can see the slide, right? Whether this is a correct program or not. So now, no response. After writing a procedure, you have to check the procedure. How will you check the procedure? Call the procedure, okay, and then you pass a symbol. For example, Z. The Z is available in the list or not, you have to check it out. So I have a symbol X and a symbol A, symbol B, and I may have Z, I may have Y, whatever. So can you call the procedure like this? Yes or no, students? Symbol is Z and the list is list of symbols. So what it will return as per this particular procedure? What it will return?
Z.
Sorry, once again.
Z, ma'am.
Yeah, it will return you Z. Yes, it will return you Z. Understood, right? Because the Z1, as per your program, you are just calling here and the condition LI is null or not. It is not null, so that it will go to the next statement, and you will check the symbol Z is car of LI. Right, so car of LI is nothing but here X, so it is not satisfied. Go to the else statement, and then we will call the same procedure by passing Z, and then list is what? CDR of LI. CDR is A, B, Z, Y this time. A, B, Z, Y. So now again it will come here. Car of A, B, Z, Y is A, right, and A is not equal to Z, and once again car of ABC, sorry, CDR of ABC is Z. Then now you will pass the data like BZY. So BZY, and we are taking B, that is a car, and that is not equal to Z. Again CDR, so again CDR ZY will go, and the car of Z you will take, and both are equal, then you will return the symbol here. So this statement will output. It will output if it is not equal to null, isn't it? Okay, so now I want to call the same function like this. Symbol equal Z. I say X within bracket, I just write Z X. Okay. So now if I give an input like this, okay, symbol is it has to be there or not, whether it is available or not. How will you check? And what is the output? What is the output of this as per this program? What will happen? This is not null and the symbol is not equal to car of, so you will pass CDR the next time, and again it is not equal, so CDR you will pass, and now then it will check the car. The car of the list is ZX, and Z is available or not. So what it will return? Whether it will return Z or it will return symbol is it symbol X. What is your answer? Because the Z is inside the list, and as per this logic, CDR, if you call, everything will go here. ZX in a list and then Z, right? So what will happen? What will happen? Car of LI is what it is referring this. Okay, symbol is equivalent to car of LI. Tell me. Okay, now I just execute and show to you. I'm going to define same thing. I'm going to define a function. The function name is symbol EQ, and I'm passing consider it as an item. And as per your program from your textbook, I'm taking the same variable, and then I'm calling the count, and then I'm checking null condition, and then I will return you false. Otherwise, I am checking equal or not. So item is equivalent to chord of x, then return x, then else I have to call the procedure. I have to call the procedure by passing an item and passing a CDR of x. So after defining it, I'm calling symbol EQ, and then I'm just passing apple item, and the list has something like your, and then you may have a orange, you may have apple. Sorry, apple is not a consider. So orange, apple, some X item. Okay. Sorry, I wrote something. So now symbol equals apple, but the given list contains elements which does not have apple. So it is returning you false. Okay. Now same thing I am writing symbol EQ and say same apple. And now this time we have element apple as well, and then I have orange. It is returning what? It is returning apple and orange. So always it is returning you the starting with the element, all the elements in the list it is returning. Okay, so once again, I call with a different data which has list inside another list. Let's say something. So please check it out here. I'm searching for apple, but in this case, apple is there, but it is giving you false. Why?
Ma'am,
Yeah.
in the code, in the PPT, you have written X, ma'am. No, you have written symbol, ma'am, but here you have written X in the code.
See, here within a single quote, whatever I'm writing, it will be considered as symbol. So this is equivalent to list of single quote X, then single quote apple, single quote Y, single quote within single quote X list apple and sauce. Why it is returning false? This is my question. Okay, so for the next session, you just execute this program, okay, and with different types of inputs, you just try it out and manually also just debug this why it is giving you F. It is always returning false. Why? Okay. So now in this session, we have discussed about the symbols and what is meant by symbol. In a Lisp language, how to mention the symbols. Okay, with a single quote we have to mention. And what is the advantage. Okay, and we have written, that means what? We can able to construct a symbol data. We can also use the selectors which will operate on the symbol data. And we also have written a procedure which will operate on the symbol data. Okay, so now this particular example I'm leaving to you why this is giving you false. Okay, but actually it has to return you Apple is available, so Apple it has to return. Okay, just to find out what is the mistake or what is the concept. Whether you have written wrongly the procedure or you are passing the data wrongly. Okay, so that one we will discuss in the next session. So if any questions, you are welcome.
Ma'am, can you hear me?
Yes, I can hear you.
Yes, ma'am, I have a doubt in the code.
Okay.
Can you share the screen, ma'am?
Yeah.
Ma'am, here in the doctor racket, you have written code, no, ma'am. Can you go there?
Yeah. Yeah.
Yes, ma'am. After the condition line, when you are checking equals to, here you didn't written the item, ma'am. You have written the X part.
Yeah. Yeah, this is right. Yeah. Because I'm returning X, that X is nothing but what? X is a list. So always it will return you the CDR part. Yeah,
Yes,
Prashantini, you have find the error. So you have to return the item. Yes. That is wrong. Yes, student. Yeah, thank you. So if you modify this X to item, you will get it. You will get it. Okay. Thank you. So as per this particular subject, every day you have to work, otherwise you will be standing or hanging somewhere. Okay, this is a little difficult subject. It's not difficult at all, but you have to concentrate. Okay, so many concepts are taught, and you can just look at, whenever we are teaching some concept, automatically, naturally, you will compare with other languages. And automatically, from your heart, you will think that whether this feature is required or not in a particular language. If it is required, we are appreciating the language, isn't it? Always the language has to provide more flexibility, right? Everything has to be supported so that the language is helpful for solving the scientific problem or industry problem or whatever problem, isn't it? So this Lisp language is a very old one, and that time itself they were thinking about the symbols, how to work on the symbols. Okay. So likewise, you can just check in Java how to work on the symbols. Likewise, you can think about C or C sharp or whatever, right? How to work on the symbols. Okay. Thank you, students, for patiently listening. And also, I ask you to read further. Let's all meet tomorrow. Thank you.
Thank you, ma'am.
Thank you.
Ma'am, can you stop the recording?